Hello and welcome to another Solana tutorial. Today we're gonna talk about the batch instruction of the token program and really do a deep dive on that because we touched on it in the previous video, but I really want to go into more depth and explore all of the nuances, like how many things can you actually batch? What instructions can you batch? Is it actually more compute efficient to do that? When is it more compute efficient? How do you decode batch instructions? So many questions. And we're gonna work with the kit again, because that's my recommended way for working with TypeScript and doing Solana stuff. And we saw in the previous video that pToken, the new version of the token program, is live on mainnet, which is the reason why this is relevant. But for today's video, we're gonna go back on DevNet, because it's the same there. So yeah, let's get started having a look at batch instructions of the token program, which is something new. This is one of the two new features of the token program that only exists since Epoch 971. In other words, that feature just came onto mainnet this week. Okay, so here we go. We did a batch transfer in the previous video. If you have not seen that, you can watch it up there. It looked something like this. We did a get batch instruction, and then we batched two transfer instructions. Cool. And we are doing so many things. What are we going to start with? Maybe the most interesting thing is what instructions can be batched, and then later we'll analyze what makes sense in terms of compute efficiency. Because obviously, maybe let's do that as the very first thing. Something like this, a batch instruction with one instruction will obviously need more compute than just the instruction itself. To prove that, we go to DevNet, because I don't want to spend my mainnet sol. So to work with a token real quick, SBL token, create a token. That's my token now. Dev that's my recipient. SBL token, create account. Because I just want to do one transfer, I create the account for this mint, for this owner, with this fee payer, and then I take this as my recipient ATA. And so now we're just gonna do, hold on, I still need a token account for myself. SBL token create account for this mint, and then from this I'm gonna transfer one token. I still need one. SBL token mint 100 of those. Oops, that's not the token, that's the token. That's not how you write it, that's how you write it. Okay, we have 100 tokens, and we're gonna, from the sender to the receiver, send one token with a transfer check. And we're gonna do that as a batch, just to see. So, quick little test. That worked. We were able to send one token from here to here, and it was a token program batch instruction that took 256 compute units. Okay, I mean, that's not a lot, but you really don't need to batch an instruction if it's only one instruction. That's a trivial case. You don't need a batch if you have only one instruction. It's good that we say that in the beginning, just in case you were to get that wrong, which you wouldn't, but I'll say it anyway, just to make sure. So let's send this non-batch instruction. Same thing, we send one token just to compare, because in that case, we're doing the same thing. We send one token from here to here, and this time it just takes 105 compute units. So that's better if we don't have to go through the batching, if we just do one single instruction anyway. Okay, fair enough. This is trivial. But then even as we experienced last time, even if we have two transfers, if we batch two transfers together, so let's first send one token and then we send two tokens, whatever, as a batch, and then we do the same thing not as a batch, let's compare those two things. In both cases, we're sending three tokens, 3 and 3, and with the batch instruction we have a total of 454 compute units. With two individual instructions we have a total of 210. So again, this is more efficient. But now we're already talking about efficiency. Well, fine, then let's look at efficiency. Sure. And as I outlined in the previous video, in this case obviously it doesn't make sense to batch those instructions. Because if they're top level instructions, then they're fine, they're efficient. It only makes a difference when you're doing CPIs. Hey, I once wrote a program that just relays instruction data. Can I reuse that? When did I do that? When I was hacking my program, right? Flash launch, that was it. Yeah, that was my program. I just give it the program account and then it uses all the remaining accounts and the same instruction data to call that program. So I can only do one instruction with this, but that's fine. Did I ever deploy this? If so, at which address? Exploit key pair. Do you exist? That still exists on definite. Looking good. Okay. I think I'm gonna recycle this. Gonna build myself a helper function. Call this through CPI and give it an instruction. Okay, there you go. Just a quick little helper that creates an instruction to that experienced program. That's what that is. And so what we're gonna do is we're gonna create this batch instruction like this, like we just had with the get batch instruction. But then the actual instruction that we're gonna send is, we're calling this batch instruction through CPI. And why you complain? Because you need instructions. I'm gonna do this through CPI. So same game. We're now gonna compare a batch instruction. When this stuff is called through CPI, what's better? Let's just showcase this first. Let's showcase with CPI. We are again just doing the exact same thing as we had so far. So again, we're transferring 3 tokens, and again, it's being done with a batch of 2 instructions. But this time, there's an overlying program that does this. And all of a sudden, we're in the range of 2000 compute units. The batch instruction again is just 454, but the top level instruction that wraps this, because it's doing a CPI, has such high compute units. This is otherwise, wait, where's the program? This thing. This is not an inefficient program. This little bit of account decoding and input checking, that's not the 2000 compute units. The 2000 compute units come from the invocation, so from doing a CPI. That's the expensive stuff. So therefore, it's better to just do 1 CPI and not 2. If we had 2 CPIs, and with that program I can't nicely split it, I could do the first instruction and then the second instruction and call the program twice. That would work. And then it would be probably roughly 4K, no, 3K, because we're doing 2 CPIs. But we're also invoking the program twice, so that's not a fair comparison. To make it a fair comparison, I would need to change that program to do 2 CPIs and not just 1. Maybe I'm gonna quickly implement that. I'll let you call that twice. The same thing, and redeploy this, and then I'm just gonna do this. So I'm giving you this transfer check to send it twice. Let's see what that would look like. Now we have 1 program call which does 2 transfer check CPIs, and then we have a total of 2700 compute units compared to 2100 compute units when we did the same thing but with just 1 batched instruction. So we are saving, I'm gonna do the math exactly, 2768 minus 2133, 635 compute units is what we're saving. So basically, we're getting the batch instruction for free because we're not doing 2 CPIs, but we're just doing 1 CPI. Even though the compute consumed from the inner call is fewer than here, but the costly thing is doing the CPI. So with the batch, overall, you're still more compute efficient. Most compute efficient is to just do those 2 as top level instructions. But usually the token program is invoked through CPI because your program works with some tokens. You don't usually use the token program on top level. And therefore, it makes sense to batch instructions. And therefore, it's good to know how that works. That's why we're analyzing this batch instruction. Okay, so it would be good to know what we can batch. The transfers are the obvious things, but you can also batch different instructions, not just several transfers. Pretty much all the things that the token program supports, right? Or are some excluded? Let's find that out. Let's do the entire thing. And now I'm not doing through CPI anymore because you got the point that batching only makes sense when you're using CPIs. Now I just want to find out what I can batch. And I'm going to go back to top level. So transfer is obvious, but what else? Let's see what other instructions the token program has. Usually when we create a token, we do everything from, let's do the entire thing by ourselves. We're gonna get a mint, we're gonna get a new key pair signer, and we're gonna create that account. For that we need the system program. Here we have the get create account instruction. So we create that account. Before we do the batch to the token program, we first call the system program to please initialize this mint account. I can pay for it. And I'm gonna assign it to the token program, and space is gonna be 82 bytes. We know that from yesterday, and lamperts are gonna be accordingly. We get from the RPC the minimum balance for rent exemption for those 82 bytes. Send it. Cool. So that's how we create the account, such that we can then do the initialize mint. And again, I still don't understand the difference between initialize mint and mint 2, but since 2 is the newer one, I guess I'm gonna use 2. I think both work. Maybe that's worth another deep dive video. What's the difference there? Or maybe we don't need a deep dive video. Both instructions initialize new mint account, but they differ in one key way. Initialize mint requires the rent sysvar, i.e. it reads the rent from the sysvar account. Initialize mint 2 doesn't require the rent sysvar. It uses the built-in invoke context. Otherwise identical behavior. Initialize 2 is the preferred modern version because it produces a slightly smaller transaction because we don't need the rent sysvar. Okay, cool. Fine. We just use 2. One account fewer. There we go. Deep dive done. What you need? The mint, the decimals, and the authority. Mint, here you go. That's the address. Decimals, 9 because default. It's not like I care really. And the mint authority, I'm just gonna set myself, my signer. Cool. I'm not gonna use a freeze authority. Or actually, no, why not? I also want a freeze authority. There you go. Cool. And it seems like the kit allows that I can use that as an instruction in my batch. Cool. So that's a batchable instruction. Great. What else could I batch? What do you usually do? You create the mint, and then you create an account, and then you mint tokens. Let's do that. But we can't batch with the associated token program, sadly, because that's a different program to call, which then again calls token keg. So if I wanted to batch all of that stuff, I would need to do a regular token account that is not an ATA. So yeah, why not? It's just a token account. Create another one like this. And also that guy I'm gonna create with the system program, but this has a different size. Get token size, which is 165. I could also say here get mint size. That's the cleaner way to do it, because that should be hard-coded 82. So yeah, let's do get mint size, get token size. And because it's the pain of my existence that I need to make this a big int, I'm gonna make this a big int. Worst dev experience ever. Okay, could be worse, but still, I don't like it. Okay, good. We created this account as well. Now we can use the token program to do a get initialize account. There's even 3 versions of this. So which one would you take? Well, the third one, because it's the newest. Each version drops a required account. Requires both sysvar and the owner account. Initialize account 2 drops the owner account from the accounts list. The owner is instead passed as instruction data, a plain pub key, but still requires rent sysvar. And initialize account 3 drops both the rent sysvar and passes the owner as instruction data. Now you know. So yeah, few accounts. Let's go. Why not? Let's batch this. I think it's also more efficiently implemented in the batch if you're using those. I read the source code once and I'm not sure anymore, but I think so, that the most frequently used instructions in the batch are checked first for efficiency reasons. So I think it makes more sense to... Actually, we can check that. We could compare how many compute units each of them take. But that's a rabbit hole. Do I even want to go down there? I'm not sure. Let's just see if we can use it as a batch. And it's gonna be fine. So what you need? The account, the mint, the owner. That's simple. Token account, the mint, and the owner, which is the transfer authority. I still prefer to call it transfer authority than owner, because owner of accounts is a program, not an authority address. But anyway, I know what you mean with owner, and I'm gonna set it to my signer. Here you go. Okay, also that, I can batch it. Sweet. So now we initialize the mint, we initialize the account. Let's mint some tokens. Get mint 2 instruction. What do you need? The mint, I have that. The mint authority, I have that. It's my signer. The amount 100 as usual. And the token, that is the token account. Might be a bit of a confusing name, but that's the token account. Mint account and token account. So here, the token account that I just created for you. And like that, I should be able to mint 100 tokens. Okay, after we minted tokens, and also that, we can put in a batch. What else would you do with the token program? Or we could burn. Yeah, let's do that. Let's burn some from that token account. Let's burn 99 tokens, 99E9. The authority was the guy who owns the token account, so that's my signer still. And the mint, so we burn some. Also that, I can put in the batch. Running out of space. Let's go. And then I could also freeze that token account of that mint. Wait, owner is the freeze authority. Why is that called owner? It's the mint freeze authority. It's a really bad name. Why do you call that owner? It's supposed to be the mint freeze authority. That's not even the transfer authority. That's the freeze authority. Why do you call that own? What? Anyway, here you go. I own the token. I can freeze. And that's not the token account owner. It's in fact the freeze authority that it's requiring here for the freeze. After we've frozen an account, we can also thaw it again. And it's gonna take the same things. I'm just gonna copy that. Here you go. And also those I can put in a batch. Okay, what else? We burn, we batch. We can do approve and revoke. Why not? Let's do an approve. I'm building a hell of a batch here. We approve for this account, the token account, 1 token. And since it's a checked, it checks the decimals and the original owner. So that's the transfer authority that I'm talking about. And then the delegate, this is the person who will get access to transfer. You know what? I'm gonna make a new signer for this. Why not? An ephemeral authority. There you go. So we're now allowing that authority to take 1 token out of our account. And to prove that that actually works, let's do a transfer check from this account and this mint. 1 token. Oh, but we need another token account to transfer to still. Should we create another account? Yeah, why not? Why not? Other token account. Let's create another account. There you go. Then we have 3 system program, create account. And then we also need to initialize account 3 instruction first for that other token account, and the owner is the ephemeral authority. And now we transfer from this token account to the other token account with the authority, the ephemeral authority, because we authorized that before. We could then also revoke. It's a bit too late now, but we could still do it just to see what that takes. We could still revoke anything that's left for this token account. I sign with my signer, but yeah, well, too late. I already stole the 1 token, or took it to the other token account. So that account is now empty, so I could get a close account instruction that will close the token account and the destination. That's where the Lamberts go. I put them back on my signer address, and the guy who has the authority for that is also the signer. And now we pretty much, I think, went through all of the instructions that the token program has, right? Almost. Wait, what else is there? Yeah, the batch instruction itself. But the batch instruction, even if it had a valid instruction in here, like this, the batch instruction is not assignable to batchable instruction. The property non-batchable is incompatible because true is not assignable to undefined. TypeScript is fun. Yeah, so basically a batch instruction cannot be batched. You can't batch batches. That's not how this works. That's why we can't do this. But all of the other instructions of the token program we can put in there. The mint, the revoke, the approve, or the sync native. But that's just for wrapped sol. I'm pretty sure that you could also batch that, right? Yeah, it is batchable. Just we don't have a native mint, so the sync native doesn't do anything. We did the revoke. We did a transfer, we did the initialize mint and the initialize account, we did the burn, we did the thaw, and we did the close. The only last thing is getting the excess Lamberts, withdraw excess Lamberts, the last thing. I mean, there are no extra Lamberts on this, but just to prove that that's also batchable, let's also put it in there. Just in case somebody sent it there in the same it's not possible because transactions are atomic, but you know, just to have it there. That token account, if it has any excess Lamberts, we want to have them. Yeah, like this, I think it's all the possible instructions that you can do on the token program, and they're all batchable. So let's send them in one batch, in one transaction, with all of the create. Let's see if that works. Let's see how it did. You think that's gonna work first time? Or you think I messed something up? Let's batch those many instructions. I think it's gonna work. I'm confident. Nope, I messed something up. Incorrect program ID. Okay, so first of all, this worked. And then I'm calling the token program, but I get incorrect program ID. Did I import something wrong? Incorrect program ID for instruction. The hell am I doing? It's just one instruction. I don't even know what I'm messing up. I just need to make sure that I'm always using the right token program. This is token keg. Yeah, this is token keg. We're always assigning to token keg. Yeah, interesting. You know what? How about let's just do a few things. Let's see where it fails really. This still works. Okay, hold on. What if it wasn't a batch, but it was individual instructions? Let's see which of those would then fail. Most of them work. Look. Da, 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 da. And then here I get invalid account state for operation. That's at which instruction now? Because it doesn't do the logs, it's a bit annoying. So 10, 11, 12. The 12th instruction. 11, 12. Oh, the withdraw excess Lamberts doesn't work because there are no excess Lamberts on it? Well, fine, I'm gonna send you some Lamberts. Hold on, I'm doing stuff with the system program anyway. Or I do, when I create the mint, I get minimum balance for rent exemption plus 1,000 Lamberts. Yo, here, have excess Lamberts. Would it then work? No. Invalid account state for... Oh, did I close the account? I closed the account and then I wanted to withdraw excess Lamberts? That makes absolute... Wait, no. You can't close the mint account. Wait, oh yeah. Of course. But the source must be the mint account. That's the problem. Oh, yeah, okay. Now it works. Doing all of that in one transaction, but with separate instructions as you would. That's not a batch yet. And then it looks like this. That looks cool. Lots of instructions, but none of them use a lot of compute. It's kind of nice. First three with the system program and then token program instructions. That's cool. And we see that in the end, there's one token on this account that is owned by the ephemeral authority. Amazing, because the other one was closed. Fun times. Okay, total compute 2,000. Well, even the small things add up. 2,400. Okay, well then let's do this as a proper batch. Let's go, because that's what we wanted to do in the first place. And this one does the same thing. We end up with one token in a token account of the ephemeral authority. And now it's just one instruction, but it's a batch of 12 instructions really. With the initialize mint, initialize account 3, mint 2, burn, freeze, thaw, approve, initialize, transfer checked, revoke, close, and withdraw excess Lamberts. And that, now it's just one big instruction, and that took more. That's 2,900 versus 2,400. But, as we said in the beginning, if it's just top level, then we're not paying for the CPIs. If all of that was done through CPIs, then doing it in one single batch would be way more efficient. Gotta change that program again. If we were to call this through CPI, it would cost us 6,300 compute units. So that's a bit more than 3K just for the one CPI, because we're comparing to 2,900 before. But if we did individual, and instead of the batch, if I did all of them individually as a CPI, this and 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 this. There you go. If all of them were called through CPI, then it would cost us not just 6.3, but 18K compute units. So, you know, CPIs are expensive. And for all of those, we're mainly paying for the CPI. We also see that the cost of the CPI itself depends on how many accounts there are, because that one CPI here, which had 33 accounts, that one CPI was more expensive than, let's say, one of those CPIs. But overall, if we're adding up all of the CPIs, it's still more expensive if we're doing individual CPIs versus one big batched instruction. And that's why, if you can, as a dev, you want to use the batch instruction on the token program, now that we have that feature. What else did we want to have a look at? Oh, we wanted to find out how many of those I could put into one batch. So let's undo this and not call it, or do we call it? Yeah, let's actually, it doesn't really matter. Let's call it through CPI. But the goal is to find out how many I can actually put into one batch now. I had 12, but maybe let's just count the burn instructions. Let's remove that. Just create an account, create a mint, create a token account, initialize the mint, initialize the token account, mint 100 tokens, and then let's slowly burn them one by one. And now I'm gonna get myself a helper. Here you go. And then we just multiply this instruction times 10 just to check if that works. Oh, because you're not sure that that's a batchable instruction, maybe? Is that what I'm losing? If I create a batch instruction from the burn instruction, that should work. But if I add those instructions, that doesn't work because it's not assignable to type batchable instruction. That type is not exported. But that's a bit annoying to work with because I can't use this. Okay, fine. Let's try this. Ha, that works. Cool. There you go. That's my burn instruction. And then I'll just put the burn instruction 10 times in here. Hey, here we go. That's how it works. Let's run this. Yep, seems to work. I can do 13 instructions with 10 burns. So I end up with 90 tokens. But we kind of expected that we can do 13. What's the actual limit? Can I do 100? I don't think so anymore. I think that's gonna be too many. Purely because with the 13, I already had 37 accounts that it needed to put in here. So I will also get a transaction size. No, actually for the transaction size, it's not that many accounts. I'm just reusing them. So that should actually not be the problem. Transaction size should actually not be the problem. But what is the problem? The instruction index 2 has 307 accounts, but the maximum allowed is 255. So yeah, there is this issue with number of accounts. But burn instructions already don't even use that many accounts. How much do they use? Like 3? Because it's always this. Yeah, it's probably 3 per burn. Okay, and I'm limited to 255. So 255 divided by 3, 85. Let's try 80. How about 80? Oh no, invalid method parameter. Version transaction too large. We do get a version transaction too large. That's weird though. Do we need that many accounts? Like, why is the transaction so big? Because the burn. Wait, does it need so much instruction data? What's blowing up the transaction? I mean, okay, yeah, instruction data for the batching is also, you need a bit. And then those accounts. So the instruction data is probably my issue then. Although, is it so bad? If that's for 10, then that's not too much. I guess it adds up. Plus I'm doing this stuff with creating the account and doing a CPI. You know what? Let's do batch many burn only. Screw the creation of new tokens and screw CPI. Just one batch of just burn instructions. And we're gonna recycle this token. That's the mint. This sus, and that's the token account KK. I'm reading stuff that I see in the token account. That's what I'm saying here. So here you go. So that's my burn instruction. Let's put just 80 of those into one transaction. Do you think that will work? Batch many burn. No, still not. Encoding is still too big. Much too big, actually. Why does it get to 2000 bytes? So 2016K is my limit. Annoying. Good that we will get bigger transactions in V1 transactions. I already looked at bigger transactions. Soon I will also look at the V1 format. For now there's just a SIMD, but eventually that will come out. But anyway, we're now limited to still that stupid low number. Fine. That way we can't even do like 60, can we? No, 60 works. Look. 60 instructions in a batch and we burned 60 tokens. Fun. And it just took 10k compute. I mean, that's still a lot, isn't it? That's just one batch, one big batch. Putting so many accounts in that one instruction, maybe that's an issue as well. I mean, because now you're taking, wow, 180 accounts and a bunch of instruction data. So yeah, that's big. How many bytes is that? I think that's my issue, that the bytes will get too big. How big was that transaction now? That was 1076. Okay. Can we go back to the thing that we did in the very beginning where we did the individual things? Which one was the smallest instruction? Maybe the revoke. Instead of a burn, can I get a revoke instruction? Then you just need the owner and the source. And the source is the token account. It doesn't mean if there's nothing to revoke, we're just gonna call revoke anyway 60 times. That should still be possible. Let's call revoke 60 times. That worked. Look, a bunch of revoke. It's also fewer compute. And the instruction data here in raw, we don't have 180 accounts, we have 120 accounts, and instruction data is also much smaller. And total transaction size here is now 500 bytes. Okay, how many revoke instructions can I fit into one batch then? Can I do 100? Yes! Whoa, that's nice. Look, I can do 100 revoke instructions. So the limiting factor actually does seem to be the transaction size, because I'm not blocked to do more instructions in one batch. I can fit a shit ton of stuff in there. Look, I have 200 accounts now and that's the data. It's a bit repetitive, but yeah, it works. And transaction size here was 704 bytes. So you think I can double that? I don't think I can double that, but I can almost double that. I can do 180 maybe. Nope, because the instruction at index 0 has 360 account references, but the maximum was 255. Yeah, that we also ran into that limit once. So even if the transaction is large enough, we can only have 255 account references per instruction, and here we already had like 200 something. Wait, what? In raw we had already 200, because we're still needing 2 accounts per revoke. Is there any other instruction that takes fewer accounts? I don't think so. You always need a token account or a mint account and an authority to do anything with a token program. So there's no instruction that does fewer than that. So it's 255, so it's 254 divided by 2. Let's go. That's still possible. Look at that. I can do a batch of 227 instructions, because then I reach that limit of 255 accounts per instruction. And also we will run into transaction size limits again, but we don't yet really. Yeah, so it seems like there's no limit into how many instructions the batch instruction takes. You're just limited by the other constraints of Solana, like transaction sizes and maximum accounts per instruction. Yeah. So as far as I can tell, 127 instructions is the maximum that you can put into one batch, and also just if you're using revoke, because that just takes 2 accounts. With the others, it's gonna be fewer, obviously. So for the burn, we reach the transaction size limit. Probably gonna be the same with a transfer. But yeah, let's figure it out. If we were to get the transfer, not even a transfer checked, let's just be efficient and do a transfer instruction. Because transfer checked, we need more accounts. Let's just do transfer. What you do, you need a source, you need a destination. I could also put the same token account Nobody gonna stop me, right? Amount 1 milli micro nano token. I think it's a nano token because I have 9 decimals. And the authority in my signer. So I transfer to myself. Let's just see if that works. Yep, I can batch 2 transfers. There we go. That takes 3 accounts per instruction, and the instruction data is big though, because we always put the amount in here. So let's see what's the maximum we can do on transfers. Let's try 64. That still works, but we are reaching transaction size limit soon. 71 also still works. 75. Nope. Then there we're at transaction size limit. So 73. Yes. 74. Nope. 73 it is. 73 transfers is the max that I can fit into one single batch instruction with current... There we go. With the current transaction size limits, 73 is the max I can do before we reach that limit. But yeah, 73 transfers in one instruction, not bad. Also, we can only just do that because we don't do a CPI and we don't do anything else in that transaction. So this is not a realistic scenario. Also, it's maybe not realistic that you do 73 transfers in one transaction anyway. Or maybe you do, like for kind of an airdrop send to many, yeah, would make sense. But then again, if you're doing top level, then you don't need the batch. You only really need the batch to save compute if you're doing it with a CPI. So is it really worth it that they added this batch instruction to the token program? I don't know. Like honestly, yes, you save a little bit, but you gotta change your program to use the batch. And I think most people are just gonna be too lazy to use the batch instruction over just calling several transfers or several instructions of the token program. We will see if people actually use it. It's here now. It was added to the token program and it is safe to use because that stuff got audited heavily. So yeah, try it out and change your programs to use the batch instruction to be even more compute efficient. You're not saving a lot, but you are saving something. And if it really comes down to squeezing out as many compute as possible, then use the batch as soon as you have 2 instructions to the token program that can be executed sequentially, like right after each other, and you don't need to do anything in the middle. Obviously, if you need to do anything in the middle, then you can't do that anymore. Because if it's a batch, it will be executed sequentially here. Yeah, but I think that's so obvious that I wouldn't need to say that. Yeah, batch instruction. I give it a 6 out of 10. Because the only real reason why we have it is to be a bit more efficient. But it's not huge gains. Huge gains we got from upgrading to P token. But that's already done. You don't need to change anything. You would need to change something in your program to use the batch. And we'll see if people do it. Anyway, one last thing that I want to have a look at for today. For now, we are just getting those batch instructions. Okay, let's get a batched instruction for a get transfer. So just do a batch of 1 transaction. And then we parse that batch instruction. What do we get out? Data instructions program address. Let's log this. So we see it's to the token program, discriminator 255 for the batch instruction, and the actual instructions are instruction type 12 with those accounts and data. So that's how it parses that. Okay, maybe I need to give you an encoding. That's what we're gonna do. Because I don't want it JSON parsed. I want it base 64, and then I can't get the message like this. Okay, fine. But then I can get the transaction. I say I have that, which is base 64 encoded bytes, and then we can put that here. Then I have here a base 64 encoded bytes. There we go. That's what I want, right? Oh wait, do I need to say encode? That's it. Encode. Oh, I keep messing that up. And then I get a transaction decoder to decode the transaction. Okay, we're getting somewhere. We have the compiled transaction and I get the message. So we need to provide the concrete accounts from lookup tables. We don't have that. And we need to provide the lifetime. So I need to get a compiled transaction message decoder to get a compiled message. That compiled message. Ha! There you go. Then I get the decompiled message. And from that message, there I have proper instructions. Look at this. And there I can take instruction 0, which is my batch instruction. And then I can parse it, No, I can't, because this is an instruction, and this expects... you know what? Hey, what do you expect? You expect... Can I just say S batch instruction? Pfft, there you go. Screw types. I know there's a batch instruction. Suck my frickin'... And then you decode this. What could possibly go wrong? Let's see if that works. Oh yeah, I'm just logging the instruction type. Let's log the entire parse. Ah, that's looking more like what we want. We have a bunch of 3, which is a bunch of transfers. Yep, look, all those transfers. We managed to parse it. Because in our batch, we're saying, hey, this is a batch. The first one is instruction 3, so a transfer. And that's the details. We could look at all of that in detail with the accounts and everything. And I could, for instance, at the parse instructions, get the first one and then look at the individual data and the program and what it is exactly. Then I would see, yeah, it's parsing it. The discriminator is 3. And the amount is 1. Cool. And that also works for a batch with different things like we had here, where we batched those 12 instructions. Let's check this transaction. Here we just gotta change that it's not the first instruction, but the 4th. That is my batch instruction. And then it should also be able to decode that. Look, now that looks like this. We have the discriminator 255 for the batch instructions. That's top level. We're going to token program. And that's the batch instruction with that data. And then the individual instructions that's parsed now from the parse batch instruction. That's the individual ones like initialize mint, initialize token account, mint to, I don't know what all of those are exactly. But yeah, the last one, 25, was withdraw excess lamperts. That's all of those that are neatly parsed. We don't have the names for them, but we have the types like these. You get the idea. We now have the individual accounts and data for those instructions in here as well. The individual data. For that instruction inside the batch instruction, inside the transaction message, inside that transaction. Yes. A lot of nested stuff. So yes, it is a bit complicated to parse this. Took me a while to get there. But it is possible. It is possible. And I think I'm gonna finish here because I'm getting tired. We saw many things, and this is not the end, because it's only just the beginning of you changing your program to allow for batched instructions. Now, personally, you might have already heard that I'm not a huge fan of this. I mean, I am a fan of compute unit optimization. Yes. And with those batches, we can optimize some more. But it also comes at the cost of, if we now parse transactions to find some stuff, to find some transfers, we don't only need to look for the transfer instructions, we also need to look through the batched instructions and go through all of the instructions, like the sub instruction of the batch instructions there, and parsing that is also a bit of a pain. But well, it's as if you added another token program with another feature, right? You gotta just update your indexers. So in that way, that's a bit annoying. But it's cool that that exists. And it's important that you know that this exists, because otherwise you might miss some transactions, or you might miss some transfers, or you might miss out on compute unit optimization if you don't use batch transfers when you could. So yeah, so what do you call that? A double-sided sword? Double-sworded shield? No, I have no idea anymore. I'm tired. But yeah, batch instructions. You can batch as many instructions as you like, as long as you can fit all of the accounts in one instruction. And as long as it fits in the transaction. Yeah, so it's fun that we have that now. I mean, we have that now. We're not discussing whether or not we should have the batched instructions. We have them, so we might as well use them, because other people will use them too. And if you don't, you're missing out. I'm just saying. Yeah, and if you need more features of the token program, you might want to look at Token 2022, aka Token Extensions, that has a bunch more features. But that's not as efficient. That's why we suddenly like Token Keg now, because it's so ridiculously efficient. Yeah. Good times with the token program. Here's some other videos that you can watch. Give this one a like and subscribe, and I'm tired. And I will see you in the next video. Yes.